My dear students, good morning all of you. Today the topic is electric potential energy and potential. So first of all, we must have an idea what is potential energy. We already studied potential energy means the energy possessed by a body by virtue of its position. That we discussed in work power energy in the first year. So here the potential energy is defined only for conservative forces. The gravitational force, electrostatic force, elastic force, these are all comes under conservative forces. So, since electrostatic force is a conservative force, then we can define electrostatic potential energy. The potential energy always implies the storage of energy. Kinetic energy implies the utilization of energy. This is the basic difference we should know. So, the storage of energy is nothing but the potential energy. Then how can you define this electrostatic potential energy? That electrostatic potential energy always states that, or sometimes is also called as the interaction energy between the charges. It is nothing but the work done in bringing a charge from infinite to a point within the electric field is called as electrostatic potential energy. Then what is the expression for it? So, electrostatic potential energy means the work done in bringing a charge from infinite to a point within the electric field is called electrostatic potential energy. The work done in bringing a charge from infinite to a point within the electric field or to a given point is called as the electrostatic potential energy. Then how can you derive expression for this electrostatic potential energy for a system of two charges? For that, let us consider let two charges Q1 and Q2 are separated by a distance x. Then the force, then the electrostatic force between them is given by F is equals to 1 by 4 pi epsilon naught Q1 Q2 by x square. This is the first thing. That means here you can always say that this is a charge Q1, this is a charge Q2, here is that infinite distance. So let us say this R you can assume, and now at a point P1 here the charge is kept as Q2. Initially, it is at a distance x. Whenever it is at this point, the electrostatic force of repulsion is in this direction. When this is moved from P1 to P2 through an elemental distance dx, then what is the elemental burden? That we have to calculate here. When charge Q2 is moved through an elemental distance dx from P1 to P2, then the elemental work done is given by d double is equal to f dx cos 180. Because electrostatic force of repulsion is towards positive x direction and displacement is towards negative x direction. So angle between force and displacement is 180. Therefore d double is equal to f is 1 by 4 pi epsilon naught q1 q2 by x square dx into cos 180 is minus 1. Therefore dw is equal to minus 1 by 4 pi epsilon naught q1 q2 by x square into dx. This is the work done when it is moved through an elemental distance dx. Now, therefore, the work done in moving the charge Q2 from infinity to a point at a distance small r from Q1 is W can be written as minus 1 by 4 pi epsilon naught into Q1 Q2 minus, that is infinity to R, Q1 Q2 by x square dx. But this can be written as W is equal to minus Q1 Q2 by 4 pi epsilon naught integral infinity to R x power minus 2 dx. This is the work done there, we got it here, and therefore once you got this one, then W can be written as minus Q1 Q2 by 4 pi epsilon naught into minus 1 by x in the limits infinity to R. Therefore, minus Q1 Q2 by 4 pi epsilon naught minus 1 by R minus 1 by infinity. Therefore, work done is given by plus 1 by 4 pi epsilon naught Q1 Q2 by R. This work done will be stored as electrostatic potential energy. Therefore, this work done is equal to the electrostatic potential energy or interaction energy. And here, this is given by 1 by 4 pi epsilon naught Q1 Q2 by R. This is the first point we have. Suppose here, if one charge is positive and other is negative, then U is given by minus 1 by 4 pi epsilon naught, Q1, Q2 by this is, if both are positive, both are negative, this will be positive. Yeah, this will be minus 1 by 4. That is, if Q1 is positive and Q2 is a negative, Q1 in minus Q2. That means minus 1 by 4 epsilon naught Q1, Q2 by R. This is the potential energy. And once you got the idea of this, suppose you will be given a concept. A system of three charges Q1, Q2, Q3 are placed at the three corners of a equilateral triangle. Triangle of side three, place at three corners of an equilateral triangle of side. Then find electrostatic potential energy of system of three charges. Suppose a system of three charges Q1, Q2, Q3 are placed at the three corners of an equilateral triangle of side D, let us say. Suppose this is an equilateral triangle of side D. Here this is Q1, here is Q2, here is Q3. And this is A, this is B, this is C points. The separation distances is same. Then what is the electrostatic potential energy of the system of three charges? Very simple. That what you can write is here, if you can take potential energy of system of charges or interaction energy between two charges. That is, U is given by interaction energy between these two. That is UAB plus UBC plus UCA. That is 1 by 4 pi epsilon naught Q1 Q2 by D plus 1 by 4 pi epsilon naught Q2 Q3 by D plus 1 by 4 pi epsilon naught Q1 Q3 by. Therefore, U is equals to 1 by 4 pi epsilon naught D into Q1 Q2 plus Q2 Q3 plus Q1. For any given numerical values of Q1, Q2, Q3, you can straight away calculate the potential energy of the system of three charges. That means, for example, you are given like this. An example, if you can take, if Q1 is equals to 2 microcoulombs, Q2 is equals to minus 3 microcoulombs, and Q3 is equals to plus 4 microcoulombs, and D is equals to 10 centimeters. Suppose you are given. Then straight away you can calculate that U is equals to 1 by 4 by epsilon naught d q1 q2 plus q2 q3 plus q1 q3. This is standard form. Then you can get that as it is 9 into 10 power 9 by distance 10 into 10 power minus 2 q1 q2 2 into minus 3, that is minus 6 into 10 power minus 12 plus minus q2 into q3 minus 12 into 10 power minus 12, because 1 microcoulomb is 10 power minus 6 coulombs, and plus 8 into 10 power minus 12. This is what you are going to get is, this is 9 into, this is 10 power 10. Because 10 power minus 1 goes up. This into 10 power minus 12, minus 6, minus 12, plus 8. Therefore, it is 9 into 10 power minus 2 into 12 plus 18. 18 means it is 10. Therefore, it is minus 9 into 10 power minus 0.9 joules. Like that, we can easily calculate. So for any given numerical values, you can easily calculate the potential energy of the system of 3 charges kept at the 3 corners of an equilateral triangle of side T. Same thing, yeah. Suppose you are given another concept here. Four charges. Q1, Q2, Q3, Q4 are placed at the 4 corners of a square of a side D. Are placed at the 4 corners of a square of side D. Then find the electrostatic potential energy of system of charges. Here you can always take that when you are given 4 charges, you kept like this. Let us say this is Q1, this is Q2, Q3, and this is Q4, let us say. And the places, let us say A, B, C, and D. This distance is D, this distance is D. This will become root 2. If you are going to calculate the potential for the system of charges, then what you are going to get here? Therefore, electrostatic potential energy of system of charges. Here, it is the interaction energy between AB, BC, CD, DA. In addition to that, interaction energy between A and C, interaction energy between B and D. There are 6 terms we are going to get. UAB plus UBC plus UCD plus UDA plus UAC plus UBD. In all these cases, the distances are taken. So 1 by 4 pi epsilon naught is common for all. Then Q1, Q2 by D plus Q2, Q3 by D plus Q3, Q4 by D plus Q1 Q4 by D plus between A and C, Q1 Q3 by root 2D plus Q2 Q4 by root 2D. These are the 6 terms you are going to get. Therefore, U is equals to 1 by 4 by epsilon naught D into Q1 Q2 plus Q2 Q3 plus Q3 Q4 plus Q1 Q4 plus Q1 Q3 by root 2 plus Q2 Q4 by root 2. So, if you have 4 charges, then there is 6 terms. This is how we are going to calculate the potential energy for a system of charges. So, interaction energy is between 2 charges. Thereafter, come to the other one, what is meant by electrostatic potential. For any given numericals, they are also simply, if you know the values of Q1, Q2, Q3, Q4, you can easily calculate. Next one is, what I meant by this? Electric potential. What do you mean by this electric potential? Electric potential means the work done in bringing a unit positive charge from infinity to a point within the electric field is called as electric potential. So, it is simply nothing but work done per unit charge, or the potential energy per unit charge is nothing but the electric potential. That means here you can define that electric potential means the work done in bringing a unit positive charge from infinity to a point within the electric field. Is called electric potential. It is denoted by V and SI units, volts. The work done in bringing a unit positive charge from infinite to a point in the electric field is called as electric potential. That means, for example, if you consider this is a charge Q, now here is a unit positive charge. This is kept at a distance. Then, in the place of Q, already we know that if Q1, this is Q1, and suppose if this is Q naught and this is Q, if I take like that, we know that electrostatic potential energy is given by U is equals to 1 by 4 pi epsilon naught Q1 Q2 by R. This already we derived. Now, if Q naught, if Q2 is equal to Q naught is the unit positive test charge, and Q1 is equals to Q, then What is that? U can be written as 1 by 4 by epsilon naught Q into Q naught by R. Therefore, in a simple manner, once you got the idea of this, therefore, electric potential, by definition, it is nothing but V is equals to U by Q naught. Unit positive test. Therefore, V can be written as 1 by 4 pi epsilon naught Q by R. This is 1 by 4 pi epsilon naught Q naught by R into 1 by Q. Therefore, this is the potential energy. Electrostatic potential is given by 1 by. Similar, if the force is known, electric field intensity is nothing but force by charge, F by Q. Similarly, if the potential energy is known, electric potential is nothing but potential energy by test charge. That is nothing but 1 by 4 epsilon naught Q by R is the electric potential. Once you got the idea of this electric potential, then here also it is always expressed in volts. Now, come to the other one, that is how to find out the electric potential for system of charges. And the concept here also will be given that 3 charges Q1, Q2, Q3 are placed at the 3 corners of an equilateral triangle. Of side D. Find electric potential at the centroid of triangle. Find the electric potential at the centroid of the triangle. This is also very simple. What you can write is here. If you see this one, this is the centroid. Here is A, B, and C. Here is Q1. So if that is the case, this is what you are given. Now you are going to calculate the potential at the point B. Suppose if this is equivalent angle, this becomes 30 degrees. So this becomes D by 2, this also becomes D by 2. So this distance is X. If this is X, this is also X, this is also X. Therefore, here first what to do is, we have to find out the distance. O is equal to CO is equal to VO, or OA is equal to OB is equal to OC, OA is equal to OB is equal to OC is equal to X. That is nothing but, how much is, if I take cos 30 degrees, it is nothing but D by 2 into X. It is root 3 by 2 is equal to D by 2X. Therefore, X is equals to D by, that is nothing but D by root 3 is equal to OA, OB, OC. Therefore, potential at the centroid is given by V is equals to VA plus VB plus, so 1 by 4 pi epsilon naught x is common, that is Q1 plus Q2 plus Q3. Therefore, it is root 3 by 4 pi epsilon naught d into Q1 plus Q2 plus Q3. This is the electric potential for a system of 3 charges placed at 3 corners of an equilateral triangle of side D, and therefore, so for any given numerical, so if Q1, Q2, Q3 values are known, we can easily calculate the potential. That means, for example, here also you can take that some example. If I'm taking here, suppose if Q1 is equals to 2 microcoulombs, Q2 is 4 microcoulombs, and Q3 is minus 2 microcoulombs, and B is equal to 10 centimeters. Suppose you are given, then how to calculate? Then V is equals to root 3 by 4 pi epsilon naught D into Q1 plus Q2 plus Q3. Therefore, what you are going to get? It is 9 into 10 power 9 into root 3 by 10 into 10 power minus 2 into Q1 plus 2 plus 4 minus 2 into 10 power minus 6. This is 9 into 10 power 10, 9 root 3 into 10 power 3 by 10 power minus 1 into these two gets cancelled, it is 4. Therefore, it is given by 36 root 3 into 10 power 4 volts. This is how we have to find out the electric potential for the system of 3 charges. And like this also we can do another concept here. 4 charges, Q1, Q2, Q3, Q4 are placed at the 4 corners of a square of side D. Find the electric potential at the center of the square. System of charges at the center of the square. In that case, here also the same point here. Now here also OA, this we can write this as X. OA is equal to OB is equal to OC is equal to OD is equal to X, which is nothing but D by root 2. Because AC by 2, which is nothing but root TD by 2. Therefore, V is equal to electric potential at the center of square is given by V is equal to VA plus VB plus VC plus V. So it is 1 by 4 pi epsilon naught into X into Q1 plus Q2 plus Q3 plus Q4, or V is equals to root 2 by 4 pi epsilon naught D into Q1 plus Q2 plus Q3 plus Q4. This is another point here. There you are going to get V is equals to root 2 by 4 by epsilon naught D Q1 plus Q2 plus. So when you consider this point here, for any given numerical values of Q1, Q2, Q3, Q4, you can easily calculate the potential here. So these are some points related with the interaction energy between the point charges. And also here there exists electric zero potential point and also potential due to continuous charge distribution. That's another point is also we have to discuss. Okay, thank you.